You ever stop and wonder how AI can write a poem or summarize a huge article, or even just get what you're asking? I mean, it really feels like magic, right? But behind all that magic, there's this absolutely brilliant concept that translates our human world into a language that machines can actually understand. So today, we're going to pull back the curtain on that secret language.
So let's get right into it. We're going to explore how a machine, a thing that's all about logic and code, can somehow grasp the subtle, nuanced, and honestly pretty messy world of human language.
And this really is the core question, isn't it? We communicate with words, with feelings, with ideas. A computer, it just gets ones and zeros. So how in the world do you bridge that gap? How can a machine possibly understand the difference between, say, love and like?
Well, the answer is surprisingly elegant. It's a technique that lets us convert all the richness of our language into the cold, hard logic of mathematics, and it's called an embedding.
So, an embedding, in simple terms, takes a word, let's say market or banana, and it transforms it into a specific list of numbers. You can think of it as a vector. And this isn't just some random code. This list of numbers is very carefully designed to capture the meaning and the whole vibe of that word.
Okay, so how do a bunch of numbers actually capture meaning? Well, the best way to wrap your head around it is to imagine we're not just making a list, we're building a map of meaning.
Right. Each number in that list acts like a coordinate. Kind of like how you can find any city with latitude and longitude, you can find a word's meaning location in this huge, complex space using its embedding. Imagine a map, but instead of 2 dimensions, it's got hundreds or even thousands, and each one represents a different little piece of meaning. Now this is a super simplified version with just 2 dimensions, an X and a Y-axis. You can see the word market has its own little spot. And look, stock is right there next to it, super close. But banana, it's way, way off in a totally different part of the map.
And this right here, this is the core logic. In this map of meaning, distance is meaning. Words with similar ideas, like market and stock, they get placed close together. And words with totally different meanings, like market and banana, they're pushed far apart. So the machine understands how similar 2 words are just by measuring the distance between them. It's that simple, and it's the foundation for everything from search engines to recommendation systems.
Honestly, this is the perfect way to picture it. It's like all the words about finance are clustered together in one country on this map. All the words for food are in another. And all the words for emotions, they have their own little continent. It's literally a Google Maps of meaning.
Now, if you thought a map of words was cool, get ready for this. Because once words are just coordinates on a map, we can do something truly astonishing with them. We can actually do math on them.
Okay, this is the classic example that just blew everyone's minds when it first came out. If you take the coordinates for the word king, and then you subtract the coordinates for man, and then you add the coordinates for woman, you won't believe it, but the point you land on is incredibly close to the coordinates for queen.
Just think about what that really means. We're not just subtracting words, we're subtracting the concept of maleness from the concept of royalty, and then we're adding the concept of femaleness. It's like algebra for meaning itself.
So what this proves is that relationships between words, like gender or verb tense, or even the relationship between a country and its capital, they're stored as consistent directions on this map. The arrow you could draw from man to woman is basically the same as the arrow from king to queen. It's the gender direction. And this ability to reason with concepts is what makes modern AI so powerful.
Okay, so we've kind of cracked how it works for single words. But let's be real, language is more complicated than that. What about whole sentences? And what about those tricky words that have more than one meaning?
Exactly. Take the word bank. I mean, is it a place you put your money, or is it the side of a river? Does our map just have one single confused point for the word bank?
Nope, not at all. Modern AI systems use something called contextual embeddings. The model actually looks at the words around it to figure out the right meaning. So bank in a sentence about finance gets one set of coordinates, but bank in a sentence about nature gets a completely different set. The same word gets mapped to different locations based on its context. It's pretty smart.
So, when an AI reads a full sentence, it's not just seeing a string of text. It's actually processing a sequence of these super rich meaning vectors, one after the other, and it's understanding how they all relate to each other in that specific order. Okay, so let's bring this all home. How does this secret language of numbers actually power the big, large language models, the ChatGPTs of the world that we interact with every single day?
This is the engine under the hood.
When you type in a prompt, the very first thing the LLM does is convert your words into these embedding vectors. Then it uses some really complex math to analyze all the relationships and directions between those vectors to figure out what you mean. And after all that, it predicts the most likely vector, the most likely meaning that should come next, and then it translates that vector back into a word for you.
You know, if you take away just one single thing from this, let it be this idea. This is the whole game. We're not teaching machines English, we're giving them a mathematical framework to navigate our world of meaning. We're turning language into a landscape that they can explore with math.
And that's the journey, right there. We start with our words, we translate them into numbers, those numbers create a geometric space, a map, and from navigating that geometry, a whole new kind of intelligence starts to emerge. It really makes you wonder, what other human concepts can we map out next?